response of laced reinforced concrete beams to fatigue loading, published by International Journal of Science and Research IJSR, presented by Dr. Hayfaa Hasan Al-Abboodi, researcher and designer at the Ministry of Science and Technology, Iraq, Baghdad. The aim of this research to investigate the influence of high loading frequency 10 Hz with a lower stress level on the behavior of laced reinforced concrete beams, to investigate the effect of the lacing reinforcement on the behavior of reinforced concrete beam under fatigue loading with different parameters such as diameter of lacing bar for 6 and 8 mm, angle of lacing 30, 45 and 60 degree with the beam axis, and lacing shear ratio. To compare the response of the laced reinforced concrete beam between themselves with the changing the above parameter under fatigue loading. The advantage of using lacing reinforcement technique in structural elements: full development of strain hardening zone and ductility of the flexural reinforcement, maintenance of concrete integrity between the flexural reinforcement layers despite a lot of cracking, limited fragmentation after yield range, restriction of compression reinforcement from buckling, high shear resistance rather than the conventional shear in reinforced concrete elements under transient blast loading. Linking the two principal reinforcement mesh together leads to improve the performance of laced reinforced concrete beams in the large deflection zone. The lacing shear reinforcement was considered an alternative to traditional stirrup in concrete structural element to reduce diagonal shear cracks and flexural shear cracks. The components of the laced reinforced concrete elements. The laced reinforced concrete elements contain an equal steel reinforcement on both faces, tension and compression, and tied by crossroad with a continuous inclined shear reinforcement, which has a role in transferring force and holding the lacing in position as shown in figure 1. The experimental work. The experimental work is composed of 6 simply supported reinforced concrete beams of cross section 0.16 meter width and 0.3 meter height with length 3 meter, and with a lacing shear reinforcement of 6 and 8 mm bar diameters. The 6 beams are subjected to high loading frequency 10 Hz with a displacement control until failure. Different parameters have been used, such as lacing bar diameter 4, 6 and 8 mm, inclination angle of lacing bar 30, 45 and 60 degree with a beam axis, and lacing shear ratio, which is depending on the number of lacing bar in each longitudinal face, 1 or 2, and lacing bar diameter as shown in figure 2. First, at the first cycle, preload is applied until the required maximum cyclic load P maximum is reached and stopped manually. Then signal fatigue loading is used as shown in figure 3. High cyclic loading 10 Hz is used by imposed displacement control with a lower stress level. This process leads to consuming time, and the stress-strain relationship for the material will be within the elastic range. The maximum load should be less than the yield load within the elastic range. The fatigue test parameter, we can see this parameter in table 1. NF, which is mean fatigue life limit, 2 million cycle, and P maximum 21 kilonewton and P minimum 17 kilonewton. PM, which is mean fatigue load, 19 kilonewton, and PA, the amplitude of fatigue loading, 2 kilonewton. PR, which is mean the fatigue load range, 4 kilonewton. R, mean the load ratio, 0.8, and stress maximum 8.85 megapascal, and stress minimum 7.15 megapascal. Finally, stress range 1.68 megapascal. Conclusion: the failure is not seen in the laced reinforced concrete elements subjected to high frequency of fatigue loading within the low stress level, in spite of reaching the cycle numbers of cycle number 2 fatigue loading life 2 million cycle, as shown in figure A and B and C and D and E and F. The comparison result show that the deflection of laced reinforced concrete beam under fatigue loading are decreased with increasing the diameter of lacing bar, lacing steel ratio, and inclined angle of lacing bar, except special cases explained in table 2. The response of all steel reinforcement, flexural and lacing steel bar in laced reinforced concrete beams exposed to fatigue loading of high frequency and low stress level is found to be within the elastic range as shown in figure 4 and 5. Thank you.